So we'll talk a little bit about proprietary versus open, the CODESYS architecture that we selected, and some tips around open automation. We came across some consulting engineers, the end users that we've had to work through to kind of do some education for the traditional automation engagement, let's put it, and how we got around that and worked with the clients. And then we talked a little bit about, as we're seeing in other presentations, the process-specific blocks, the value of investment of intellectual property into creating these objects. We've seen is fantastic because we look at when we make an investment into CODESYS, we have that we can amortize it across multiple clients, projects, and hardware platforms versus something that we would deploy in one platform and have to stick with that manufacturer. So a little bit about one typical project that we had. The client had Siemens and Schneider. They had been there for Siemens for nearly 30 some years. And over the legacy system upgrades between control platforms and things like that, they weren't well documented. Version updates were an issue. Even the programmers, factory programmers that paid, premium for, had different methodology. There was no standardization, as you would expect, even from a system integrator. Some from a standards or deployment or serviceability. Even within the large corporation, they had a hard time finding programming resources. So even the programming resources that they were being delivered to the site at premium were not versed in all the different technologies. A new object in TA Portal wasn't available to these technicians. They weren't certified. They had to outsource it internally to other offices, things like that. So becoming a source of frustration, becoming a large cost investment. And so the customer had come to us to kind of, what were the options? Over the years, they engaged multiple consultants, mechanical engineering, typically in designing of new facilities for them. And the consultants would see that Siemens or Schneider and hand the specification or design over to them, which essentially put it back into even further into the design process, into the proprietary platforms of each of the respective vendors. So every controller that they purchased, they basically put themselves deeper in the hole. And we tried to explain that. We've often talked to consultants and end users about extending legacy platforms and where do you cut the cord. And so we just had a project. This is a recent specification. And this is the exact verbiage that came from the specification that was on the street. And the contractor was responsible for extending all new remote I/O panels to have Rockwell Automation ControlNet. As most of you out there know, ControlNet has been obsolete, but it's continued to be sold. The client continues to buy that and install it and puts themselves further into the hole that the day that is truly no longer available, they have a challenge to buy themselves back out. So we're trying to educate a lot of the industry into how do we make an open solution and how do we make it repeatable as well as supportable. Another consultant came back to us and said, we're going to specify the most open PLC solution. Specification came out, sole source Rockwell Automation. When we questioned that and the end user ended up questioning it, it was due to the large base of integrators familiar with the platform. They're the most open solution. And that was from the sales, obviously the distributor salesperson through to the consultant. And neither CODESYS, which we had tried, Siemens nor Schneider, was considered due to limited support, as they meant, as that was their education base. So after we continued to educate the end users, they started to realize that CODESYS was much more pervasive than was previously known. So a little bit about the closed versus open architecture. And we kind of just used this slide with them a little bit to explain, well, anybody that has an iPhone versus an Android, you'll see that closed ecosystem versus open ecosystem, and what are your options? Um, on a proprietary hardware software solution, we do see obviously there's limited access to third-party applications. The ecosystem is tightly coupled, and it's integrated. Less configuration. And as people say, "Oh, we love it," but you're also paying a significant higher cost for not over the life cycle of the project, but maybe that initial capital investment. If you buy all my drives, all my displays, all my PLCs, all my software, it'll work, but the price will, significantly higher, and certainly over the life cycle will be. So once you own it, it will cost you long in the life cycle. Across the life cycle, as we've explained. The vendor distributor typically discourages, when we've heard this from numerous clients, they're discouraged from using any third-party components. Don't use any third-party I/O. Don't use a different operator. It may or may not work with us, or the support of it. And I'm sure many of you heard that out. There is vendor-specific IDs. So when you buy that platform, you have to purchase that Studio 5000, that TI-8 portal, the EcoStructure, to program that device. Very limited ability to reuse code. You can't typically move that code from one platform to the other. In addition to that, you're paying a significant licensing cost, not only in the initial acquisition of it, on the client's capital project or yours, and the maintenance cost to the client. Oftentimes we see specifications where clients are asked to, are us to provide copies of the software to the end users that don't have programming capabilities. So, but invariably they pay the cost capitalized for the software, and then they get a bill that next year for support of it that they will never use. Again, the hardware has typically a proprietary runtime and operating system versus Linux. And other times, whether it is using Linux as the base, it's hidden, and a proprietary runtime is kind of encapsulated. Versus an open hardware and software solution, which is where we typically try to push the market to. There's a much larger pool of community offerings that help us extend the platform. Our engineers will go out and look for things that the client needs and some examples. And we typically, with the ability of CODESYS to have higher level languages to interface with, Docker and things like that, we're able to extend it and really add some best in class options for the client. While those distributors, like anyone, would want to enhance their sale, they do typically, vendors of CODESYS based products will promote the openness of the platform and the ability to use third-party components interchangeably. Certainly, they'd love to sell whatever products they have and their whole suite of tools, but recognize that it allows them to have more sales, higher volumes, and the ability to give their clients the best-in-class systems. Being that it's vendor agnostic, that IDE, that investment in learning that your client has, really gains across all the platforms. So being able to have that CODESYS knowledge base across ABB, Altus, Bear, Wago, Phoenix, it repeats, and it gives the client a sense of flexibility, as well as the ability to have some cost savings in the long run. The portability, the ability for us to move platform to platform, is a huge selling point. If you treat the client well, rarely does that happen, but it does give the client the ability to, if that particular hardware CPU is obsoleted, they're able to move it within that vendor or to others with minimal rebate. The other nice thing is the free IDE compared to the licensing costs of other vendors. The open runtime and its extensions, and obviously the ability to have a typical open options of what you want to run the platform. So this was from a recent article, and I hate to be picking on Rockwell, but it's typically easy. As we talk about, use of a proprietary approach has been part of its products to maintain control over its technology. It supports its business model. It ensures the security and performance of the system. So again, and it's been a long-standing strategy in the industrial automation space, but although the industry is shifting towards a more integrated open system. So we see it, all of us on this call being supportive of CODESYS, see that the market is shifting. The world is shifting from the proprietary hardware software solution, and know that that's supporting large business models and businesses, to the open solution that's across the industry. So, and again, these are some of the things, slides that I typically use with our clients and talk about as far as CODESYS and its use in the process space, as well as the flexibility why we've chosen to recommend. Being that it's hardware agnostic, we've eliminated virtually a lot of the gateways and in-rack protocol converters. We have a flexible solutions for I/O platforms that we can select from multiple different vendors. We could stay with one vendor or decouple it to any vendor we want. We can leverage advanced in IT and OT environment. So some of the advanced cybersecurity and integrating some of that information down into the processors that have that capability adds additional features. The CODESYS runtime, being standards-based in the IEC 61131, allows us to have flexible code that we can develop. The ability to have multiple protocol support in the processor eliminates the need for in-rack and other different gateways. So again, a lot of the things that we've spoken about really give, I use the term of the Swiss Army. It gives you all your little tools that you can use towards optimizing your project. So some of the examples, and we'll talk a little bit, some screenshots of objects that we've created for industry in the process market, such as rotork and Alma valve objects, the ability to have drive objects and pumps, standard objects for motors, pumps, chillers, packaged pump stations in the water wastewater space. This just gives a little example of the ability to, as we talked in other slides, mix and match with CODESYS being the core. Select the best-in-class protocol for your field bus. Select the best CPU for the application. Select the best I/O platform for its I/O density, robustness, whatever it may be. Vendors, the ability to have his stock room with one specific part across multiple applications, and the ability to extend their architecture. So one of the selling points of the projects that we're going to highlight today was the ability for CODESYS to support multiple protocols and the flexibility for it to integrate with other systems that they had in their facility. So we talked about the open standards that they support as BACnet and Ethernet IP and Modbus and OPC UA, MQTT, SNMP. Those were all being kind of utilized to kind of roll together a comprehensive project. But we looked a little bit about extending these other options into Docker, things like that we used for the application. We've used some of this weather plugins, which we'll talk a little bit about in the next slides, for industries such as utility plants, the cannabis industry, the wastewater market, things like that. This slide's just outlining to the client about the IEC 61131 that we're all familiar with and the power behind it. But really, the slide becomes important when we show the clients the ability to mix and match those programs, which the other vendors have too, but the ability to take that and have it be portable. So it's a bit of an education to understand how this platform allows us to take the code and the investment really and move it from platform to platform. Now the ability for CODESYS to support OPC UA at the core and at the controller level really allows for flexibility of different applications, the ability to have some redundancy, such that if the server and the SCADA server were to go offline, that we natively, with some third-party tools, can data mine or through WebVisu be able to have some visualization and some basic control, as well as reporting tools and things like that, can data mine directly from the processor. It was interesting. We took this slide from the client happened to buy Iconics. So as we were doing their standard presentation, I was going through this, and it was the ability to kind of show the flexibility and power of CODESYS. We started to show little, as you can see, CODESYS icons near the vendors that were using their platform. So you see, just some of the slides here, we were able to say, here's all these vendors, and this is a small list of that use CODESYS at their core. So one of the things that we talked to the consultant about was really, how do you go about and specify an open system? So we talked a little bit about CODESYS and how important it was, and how the selection of open field buses, not being married to in-rack IO from vendor A, and not being able to move across platforms. But oftentimes the engineers are, how do we go about specifying? ISA 112 is a little pitch about a standard that's being developed right now. I sit on the committee, and it's really interesting of this layered approach to specifying the life cycle of a SCADA system. And you'll start to see that some of the things that are in here, an open platform becomes very much important when you specify the life cycle, how you specify the right solution. And we'll talk a little bit about processes, the system standard, the development of it, specification and of hardware, how do you deploy it, commissioning of it, but really the documentation part and all the things of coding become really, really important in this overall life cycle. So this new standard will basically help support that, help consultants and users and integrators kind of come up with the same standard across the world. And so we talk a little bit about, with consultants, about specifying the field bus, selecting it, working with vendors, picking the right field bus for the application. Is it Ethernet IP? Is EtherCAT better suited for you? Where are you located? Is there more prevalence of Profinet or something like that? So being able to select it or being able to interchange them. The beauty of it is maybe the application was well developed in North America, but maybe where it deploys Profinet IO and everything is much more prevalent, and they can make a decision to switch the IO substructure if they want. They have the flexibility. Specifying the controller, communications, how many ports do you need? So the ability of picking the hardware, the best-in-class hardware, and selecting the best-in-class field bus, as well as IO structure, gives you that menu of those layers that you can pick without having to purchase just that one platform from one vendor. We think that's really critically important. We talk to clients about that. We really talk about, selecting the right sequences, developing those, reusing those, investing in them, but being able to move that across any platform agnostically. Are there OEMs involved? We try to talk to them about selecting an open solution. Oftentimes, they're not as excited about that. They have their solution that they deploy, whether it be Rockwell, Schneider, Siemens. We've worked with some of the consultants to put verbiage in that if they want to do that, that's great, but they then need to provide some additional tools so that the client has support. And there's additional incentive for them economically not to do that and potentially go to a more open platform. The ability of having that open platform allows them to work with all their equipment that shows up at their plant. So, specifying network and security zones, again, planning cybersecurity into the design. So that is part of the life cycle of SCADA. It's part of many of the other standards, for, the Purdue model and things like that. But that should be part of a consultant's planning for a system. More often than not, it's not. And so we try to educate the clients on that. And we have other slides that we use when we talk to clients about specifying each in component in depth. This is a little bit of the ISA 112 model. And you'll see how CODESYS, in some cases, transcends a bunch of the models of the layers. And through either MQTT or different protocols, we are able to reside or operate and communicate up through the layers without any middle components. So it adds, just a discussion point talking about how maybe a SQLite in a Docker can be pushed up to the historian and things like that, kind of bypassing the other components and layers, giving you some flexibility. But this model is part of ISA 112, and you'll start seeing that more and more in the future. So a little bit about the architecture of this project that was process related that Chris and I talked about presenting. This initially was started as a fault tolerant pair of processors. As we got talking with the client, flexibility, objects that they wanted to have redundancy at the equipment layer, as well as having kind of a do once template and repeat. We actually increased the node count. There's more controllers. There's each controller is doing a little more at its local layer. So we have chillers that we have objects written. We'll show you with chiller blocks for a couple different vendors that they happen to have. We made faceplates for them. The processor on board, while it's communicating to the processor of the chiller, it's also doing the control of the chiller as well as the ancillary flow, temperatures, pressures, and that. And then they all communicate back up to a layer processor that's doing some of the balance of plant control. We're doing energy optimization on pumping systems, chilled water condenser systems, power controls. We're doing these pumps range, and we'll talk a little bit about the anywhere from 800 horse down to 200 horse. And so we're using the CODESYS with Docker and extending some different options into it to give the customer some flexibility. We have extensive communication that's using Ethernet IP, Modbus TCP, some BACnet, obviously OPC UA. The client asked for some isolation to some third-party systems using Modbus RTU, switching to BACnet, so serial to Ethernet to different protocols, just to give an additional layer of cybersecurity for data share. All the systems have large valves. The manufacturer happens to be ALMA in this case. We communicate and have an object written for ALMA valves that we have a faceplate for, and that allows us to have repeatable control functions for every valve. We just drop a block in. Just a highlight of the optimization we're using, like we talked about, BACnet, Modbus, Ethernet IP, BACnet, different protocols, and all of those interacting with the over probably 11,000 tons of refrigeration, 200 to 800 horsepower pumps. There's about 11 of them in the process. So we're constantly maintaining pressures and temperatures and flows. We're taking some real-time weather data, optimizing tower control, trying to manage energy. That's really the goal, energy efficiency across the whole board, as well as the process operating. We selected some of the benefits of using the open platform. We work with the client. We love the ability of being able to portability of the code. So that code is developed, the objects are there, they can be moved to any type of processor with a runtime. The use of OPC UA and the ability for that to interact with other subsystems as well as their CMMS, generating work orders, things like that automatically. We're able to pull real-time weather data directly into the PLC through third-party app, as well as into SCADA. We connect directly to an on-prem weather station or Modbus. So we're able to get real-time data over the weather service, as well as local on-prem data, and be able to intelligently select it and control the process. We have some apps such as Node-RED with Telegram, kind of as a backup to SCADA falling and things like that. So they have the ability to have some alerting and things that hit the controller outside of just an email. They can have some interactive messaging with the controller. In localized data logging as required. More importantly, the largest part of the project and the selling point of it was the protection of the intellectual property. So there are some companies that charge upwards of $250,000 plus for just the software application running on a PC, doing some of the optimization algorithms. This client's willing to invest, but we're investing in the CODESYS platform so that once that's developed, that becomes kind of future-proof. It's not proprietary, and it's the ability to migrate it from platform to platform as required. So we're standardizing the objects, investing in that IP, but being able to reuse that and make it repeatable. Just some examples of that. This is an object that replicates directly what's at the chiller itself. So we're able to move slides here. So that data that's coming from their processor, we're pulling it in and being able to move it back up to them. And that's will be eventually pulled through WebVisU up through SCADA. And we're able to get compressor information, refrigerant levels, pressures, evaporator, condenser, all that kind of stuff. This is base plates that we built, and you see more and more of it across all of our presentations. Everybody's trying to create the object, the faceplate, usable code, and that's the name of the game, and the value for the clients. Where you're having reusable faceplates and code drilling into drives, valves, motors, taking your advanced object and bringing that valuable data up to the customer. Same thing with the drive versus a motor or a pump. You're able to pull more data out, making it more beneficial for the client without having extensive licenses like some of the other plant packs or things like that, which they deliver this at a much higher level. This is a WebVisU faceplate taking data directly from a valve. This happens to be Rotork at the time. You make the object, and we've added the features in there. We can enhance that, but basically allows the client to interact with multiple different actuators, not within one platform, as proprietary PackScan was within the Rotork environment. Originally, they tried to have it as one deployment of their solution and wouldn't let any other valves onto that network or allow the client to connect any other valves through the system. We were able to, with CODESYS, open it up and allow them now to have multiple valve companies within the network, and the valves all can interact with the faceplate, kind of agnostic, allows them to interact with everything pretty uniform. Flow object, standardized flow objects, so that regardless if it's a magnetic meter or orifice plate or anything like that, we're able to do all the calculations, do the totalization, present the data to the client so that he's getting min-max, his statistical data right from his controller, and that's interactive with the process. This is a little bit, obviously, Matthew and I, Knight, who was in the previous presentations, operate within the water wastewater space quite a bit. And so we've taken that standardized lift station, pump station objects, and we've done a block for it and tried to create that all in visualization for the client. Drive systems, a similar process. Create a drive, library of VFDs across multiple manufacturers, and create faceplates to let them operate it without understanding or needing to know the different vendors' interactions. So whether it was the Yaskawa drive, an ABB, an Eaton drive, it doesn't matter. Under the hood, we take it through, we pull all the data up through SCADA, but minimally the faceplates have the same information. So you can see here, this one happens to be, I believe, an Eaton drive, an Invertech drive. The other one was a different model. And all of that data that's within the drive is pulled through. And based on how much data is there, but we take that select of data and make that into a faceplate so they can operate the drives.